yesterday we just gone through the structure of glucose, right? At the same time, we also saw it that the structure of glucose is not necessary that it should be always linear. It can be cyclic, right? Now, what was the reason? How can I say that it will be having a cyclic? We saw it yesterday in the lecture that it does not give addition reaction with NaHSO3, right? Though it contains aldehyde, though it contains carbonyl group, it did not give the addition reaction. Even it does not give the reaction with the Skiff's base, right? So what is the reason for it? It's aldehyde, the group of the aldehyde which was present in the linear structure. It becomes absent when it gets converted into cyclic structure. But during the conversion into a cyclic structure, while it is getting converting into from open chain to cyclic structure, what is going to happen? It's going to break its double bond oxygen which is present. It's going to break its one of the valency. Right? That means what will happen? Carbon will be there with the deficiency of the valency. Right? At the same time, oxygen is also there with the deficiency of valency. How they are going to get bonded? They will convert their valency to the fifth carbon. They are always going to get cyclization to the fifth carbon. The reason is they are getting cyclization in the form of pyreno structure. They are going to produce as a pyrene. What is the structural formula of the pyrene? It's a heterocyclic ring. Till now, in the chemistry you have studied it, benzene, right? And its compound. All the benzene and its compounds are considered to be the benzene having all the 6 carbon atoms. Same carbons in the cyclic structure. They are considered to be as a homonuclear, homocyclic compounds. Right? Here what we are going to get it is 5 of them are the carbon. 1 is oxygen in the ring. They are known as hetero compounds, heterocyclic compounds. Right? It's not necessary that every time we will be getting it as an oxygen only, but here particularly when we are studying about the glucose, it's getting it as one oxygen. The structure is like pyrene, right? It's also having an alternate double bond present in it. It's like pyrene, right? But we generally don't show it, the presence of its valency, right? Resonance. So this structure is generated for it, and when it is possible, if only 5 carbons are bonded with it, right? If I consider this is my first carbon, it's from the CHO group, what will be getting it? Second, third, fourth, fifth carbon and the first carbon is having common oxygen. First and the fifth carbon is bonded with common oxygen. That means this oxygen is going to remove it. It's going to get it as a valency of the oxygen. Now, why I remove the OH? I can't put oxygen over here because that won't be able to get stabilized over there, and that's the reason why we are putting it as an OH over here. At the same time, we also studied it that it contains 5 OH groups, so they should remain as 5 only, right? So we got it as an OH group shifted to the first carbon, and the oxygen, the carbonyl group, gets bonded with the fifth carbon. This structure actually it's been plotted with 2 valencies of each carbon. One is shown with H, OH, H, OH. We will be having it as an CH2OH been outside the ring, separate, and that's the reason why we are going to produce anomers. We are having it as an cyclic isomers in the heterocyclic compounds. We are having it as an anomers. These are known as anomeric structures. Right? What is the change? This H comes over here, OH goes over there. The change is created. You can see it in your textbook. The structures are given to you. Both the anomeric structures of the are given, which are indicated as alpha and beta isomers. Alpha and beta anomeric structures. Right? The position of H and OH has been interchanged. The position of H and OH has been interchanged. They are also acting as an isomers. But these molecules cannot be separated. They cannot be separated. Whenever I am going to get the glucose molecules, all the glucose molecules, I can't say that it is in the form of alpha structure or it is in the form of beta structure. The reason is they are not only going in for the anomeric interchanging of the positions, but they also go in for open chain. They go for the resonance of the open chain. Right? So all the glucose molecules are combined together and we don't write them as an isomers. अब तक सीखा था सेम मॉलिक्यूलर फॉर्मूला है तो आइसोमर्स कहते थे. यहाँ पे सेम मॉलिक्यूलर फॉर्मूला नहीं होगी, सॉरी मॉलिक्यूलर फॉर्मूला सेम है, स्ट्रक्चर डिफरेंट है, लेकिन उसके लिए वर्ड यूज नहीं कर रहा हूँ आइसोमर. उसके लिए वर्ड क्या यूज कर रहा है? एनोमर्स. रीजन क्या है? साइक्लिक स्ट्रक्चर भी बन रहा है, लीनियर भी बन रहा है. ठीक है, इसलिए वर्ड क्या यूज कर रहे हैं? एनोमर्स. और वो भी चेंज कहाँ होगा? फर्स्ट कार्बन पे. तो चेंज होगा कहाँ होगा? फर्स्ट कार्बन पे. अल्फा एंड बीटा आर द एनोमेरिक स्ट्रक्चर्स ऑफ इट. ओके, इज इट क्लियर? एंड व्हाई दे आर साइक्लिक? Sorry, why they did not give us addition reaction with NHSO3 or with Gibbs base? The reason is they get converted into cyclic structure where aldehyde is not free. Aldehyde group is not free. That will be our reason. Okay. Now this was for the cyclic structure. We got it linear and cyclic both. But at the same time, when you are having it as a linear structure, when you are having it as a linear structure indicated over here, okay, we indicate it for it capital D, right? We also indicate it as plus, and then we indicate it as glucose. Okay, what are these factors indicating to us? They are particularly for the linear isomers. They are particularly for the linear. This capital D. Or if I change the structure, for it capital N. For it, the word we are using it as a capital N. What does this D and L indicates to us? Yes? They are not dextroleo. Dextroleo were indicated with small d, small l. Whenever this isomerism, this is one of the part of the isomerism. Whenever the isomers are shown for the dextroleo, they are indicated with small d, small l, or with a plus or minus sign, which we are showing it for the glucose separately. Plus or minus sign. We are going to get it as D plus D minus L plus L minus. All the four possibilities are there for the glucose. Okay. So what does this capital D and capital L indicates? It's a position of priority of the functional group. It's indicating it as a position of the priority of the functional group. Those who are going in for the entrance exam, maybe for the GEE, maybe for the NEET, you are having it as in two different another isomers to be studied. which are termed as capital DL nomenclature, RS nomenclature. You are going to study the two different vectors, and these two are based on the priority sequence. Right? What is the meaning of these two? Capital D, capital L, or capital R, capital S? DL indicates D means the position of the prior group is on the right side. Position of the prior group is on the right side. L indicates position of the prior group is on the left side. Right? In place of, this is only for the position. At the same time, this is a complete rotation. So it is written as RS. Right? Rectus, sinister. These are the name of them. Right? How to identify them? How to identify for these compounds? So for that is the first factor that you will have to identify. That is how many chiral carbons are there. The first factor you want to identify chiral carbon. Now what is chiral carbon? Carbon having all its 4 valency with different functional group. Right? Here if I am going for it, what is it shown to me? One is H. Out of 4, 2 of them are with same oxygen. Right? So these are all not the 4 different valency. It has 2 identical valency. So it's not in chiral carbon. Now I am going in for this carbon. It has OH, H, carbon, another carbon. Should I consider it as the same or different? Should I consider it as same or different valency? Different. They are different. Right? It's like students in our classroom. If specific friends are present, their conditions are different. Their specific friends are not there in the classroom. They are having another friends, but specific friend is not there. They don't like in the classroom. Right? So that is known as atmosphere surrounding to it. ठीक है? जो अपनी क्लास में मस्ती करते हैं वो कहाँ बैठते हैं? अलग बैठते हैं. चलो सारे मस्ती करने वाले एक जगह. हाँ? जो पढ़ने बैठे वो सारे अलग. एटमॉस्फेयर चेंज हो जाता है ना? हाँ? अगर गलती से कोई टीचर आपके क्लासरूम में परमानेंट अगर एक मस्ती स्टूडेंट हो जो बहुत खेलता हो, कुछ दूसरे को पढ़ने ना दे और उसको आपके बाजू में बिठा दे, तो आप पढ़ सकोगे? पढ़ पाओगे? दिक्कत आएगी ना? प्रॉब्लम आएगा कि नहीं आएगा? पढ़ने की बात कर रहा हूँ. ठीक है? शुरू कैसे किया उन्होंने? ठीक है? All of you have understood. I don't want to use the words. This is the atmosphere around it. It contains double bonded oxygen. It contains single bonded oxygen. Its atmosphere has been changed. Right? So both these carbons are different. So this is chiral carbon. Now let's check for this. H, OH, again carbon. Right? Is it chiral or not? Yes. Is it? Why? It contains OH, H. It also contains HOH. Its fourth valency is different. It's again the valency is by CHO. This valency is by a totally different group. So again this is going to be considered as all the four. This is not a chiral carbon. Right? Okay. Now out of this, once we got a chiral carbon, there are a number of chiral carbons. We don't have one. If we are having only one chiral carbon, it becomes very easy to identify the position of the functional group. So when you are having more than one chiral carbon, the last chiral carbon you have to check the position of the priority group. What you have to do it is find out the last chiral carbon and check the position of the priority group. Now in this we are having 4 of them. which one is the last. So what we do it is, we number it. We already know it that this is number 1. So this is going to be 5th. And that is my last chiral carbon. So I have to check its position, priority group. This is 1, this is the second group, third group, fourth group. So 4 valencies are there, right? Out of which the priority group I have to identify now. Now how to identify that priority group? At present my priority group is OH. But how did I got it? We are having groups. We'll discuss it later on, right? Where is the priority group on? Right side. So it will be indicated by capital D. In this my priority group is on. We told it OH is our priority group, right? It's on the left side. So it is indicated by capital L, right? It does not mean that if OH is on the right side, it's an R or it's an dextro or Leo. Dextro or Leo, you already studied in chapter number 10. They can be identified only and only by allowing the plane polarized light passing through it to know it whether your plane polarized light is rotated on right side or left side, that is clockwise or anti-clockwise. If it is clockwise, we get it as dextro, right? But that is only by plane polarized light. So structure cannot help me. But from the structure, whether it's a D or L, the nomenclature is indicated for me. Okay? Now, the rule to find out why did I take out OH as a priority. Why the OH is a priority. So for this, to identify the priority, whenever you want to find out which group is prior, what is the first rule indicates? You are having 2 rules. First rule, whose atomic, the chiral carbon attached to the atoms. I am not saying attached to the molecules. You are using the word attached to the atoms. More the atomic number, higher is the priority. More the atomic number, higher is the priority. Right? So in this case, if I go for it, carbon is attached with oxygen, carbon is attached with hydrogen, and carbon is attached with 2 other carbon atoms. Right? Atomic number of hydrogen is 1, carbon 6, oxygen 8. More the number, higher is the priority of that component. And that's the reason why OH was a prior group. Okay? And the second rule is given to you. If both of them are having same value, same atomic number, like we are having it suppose for these 2 carbons, right? Same carbon number, atomic number is same. Then which one should be considered? More the mass, more is the priority. The mass of this component, it helps me very easily to identify. So this one will be the priority. So first, second, third, fourth. The number of this priority group will be given out as first, second, third, fourth. Okay? और ये नंबर देने के बाद RS के रूल्स को अप्लाई करेंगे, वो सीख लेना कुछ लोग मेरे काम करेंगे, मैं नहीं सीखूंगा. ठीक है? जिसको सीखना हो फ्री पीरियड में मेरे पास आके सीख लेना. Right? Is it clear? DL. How to identify the DL? What is the rule? First of all, we have to find out the chiral carbons. If I am having only one chiral carbon, no problem. If I am having more than one chiral carbon, I have to number to the carbon chain in such a way that I get the last chiral carbon. And to the last chiral carbon, I have to check the priority sequence. Right? And on the basis of the priority sequence, I have to check out prior group is on right side, capital D, left side, capital L. These are not extraneous. ठीक है? एग्जाम में ग्लूकोज का कोई भी स्ट्रक्चर बना के देंगे. ग्लूकोज के कितने आइसोमर्स, ओपन चेन आइसोमर्स कितने पॉसिबल है? अगर आपको ग्लूकोज के ओपन चेन आइसोमर्स पूछ लो कि ड्रॉ करो तो कितने करोगे? 2 तो ड्रॉ किए मैंने. ऐसे कितने possible है? Again, this is one of the objective multiple choice question for chiral carbons when you are having optically active compounds. How many are possible? Stereoisomers. I am talking specifically only for stereo, not chain position structural. I am not talking about structural isomers. Only for stereoisomers. And this is as a part of your MCQ, maybe in your board exam also. How many possible isomers are there for the open chain? You are talking about only open chain. How many are possible? So for that, you are having it as a rule. 2 is to n, where n is the number of chiral carbons, and where n is the number of chiral carbons. Right? How many are there? 4 chiral carbons. So what should be the answer? कितना बना है? 2 raised to 4. 16 isomers are possible. How many are possible? 16. Again, this is a formula conditional. It's not applicable everywhere. It's a conditional formula. Compound should not contain mesoisomers. They should not contain mesoisomers. Conditional है ना? इसलिए सभी जगह पे अप्लाई नहीं करते हैं. मैंने ग्लूकोज के लिए सिखाया है. फिर ये नहीं कहना सर सभी जगह पे अप्लाई नहीं हो रहा है. Clear? Clear to everyone? So that is what we are having it for the carbohydrates. ये जो portion था वो किसका था? Carbohydrates. Now additional to that, you are having another compound after glucose, fructose. Right? For the fructose, we are not being given out anything in the detail for it. Neither the reactions are given to us. But in exam they can ask you. Because we have already studied chapter number 12, aldehyde ketones. Fructose, we are having ketone, right? Ketone is present as a functional group in it. So how can I identify that the ketone functional group is present in the given compound? How can we identify that the ketone is present in the given compound? Why? Tolerance is ketone going to give me tolerance test? So how can I identify? Good. We are having only one test for it. That is iodoform test. Okay. And what's the condition for the iodoform? We already wrote in the condition. CH3 C double bond O. This is the compulsory functional group should be present with it. Carbonyl group attached with CH3. Can you show it to me in the fructose? Can you show it to me in fructose? Where is this group? Attached with the carbonyl. Is it there? Is this group present? No. Still it goes for the iodoform. Still it goes for the iodoform. What is the reason for it? So again for the iodoform, make it sure even in the chapter number 12 while you are studying it. Iodoform test is given by those compounds which are having primary OH group attached to the carbonyl group. Primary OH should be attached to carbonyl group. Okay? Is there? This is the primary OH helping me to make the reaction. Right? Okay. So this is going to give me the test for it. At the same time, the another thing, it also produces NMR. It also produces cyclic structure. Not only the linear. Fructose also produces cyclic structure. Cyclic structure is between second and fifth carbon. In glucose, C1, C5. Here, C2C5. The linkage we are going to get it is between C2C5. Because of this, what will happen? We are having only 5-membered ring structure. In the previous we got it 6-membered ring. Here we will be getting it as a 5-membered ring structure, which is equivalent to furan. The structure you are going to get it like furan. And that's the reason why these structures, cyclic structure, are known as furanose structure. Right? Glucose को pyranose कहते थे, इसको furanose कहेंगे. 5-membered ring intracyclic ring है. Okay? Clear? That's what we are having it for. The thing that for the fructose, we don't have anything much detail for it. Okay? Clear? Rest of the part is eliminated from our syllabus. So rest from the next chapter. In the next lecture we will be going through proteins. Right? Okay?